Hello. So in today's video, we're going to keep exploring trigonometry outside of right triangles and what that means and what that looks like, because trig is supposedly ratios of sides of right triangles. So how do we do it when we have, for example, sine, cosine, tangent, working we have right triangles? What does it mean to have trig ratios for angles bigger than 90 or for negative angles? So yesterday we did, or in the last video, sorry, we kind of looked at the fact that you can do cosine of 30. And anytime you have a 30-degree angle, you get this ratio of adjacent, right? So right here, the adjacent to the hypotenuse, so this side to this side should be 0.866. So one way to do that is to say that this would be 0.866 and this would be 1, because then I'd get the right ratio. But again, it didn't make sense to think about a right triangle with an angle of 150, right? Because if I have a right triangle and this is 90 degrees, there's no way I can have 150 or 210 or negative 150. So we're sort of exploring this, but there's answers. The calculator gives me answers, mathematicians have answers. And we learned it has something to do with this, putting any angle we want in a standard position where we have an initial side right here. And then we can pick somewhere else in the system, and this would be my angle. Boom. And we're still not sure how we get trig ratios off that. And I don't think we're going to quite get there today, but we're going to take the next step. So the next step is to learn about this thing called the reference angle. Okay? Because it was also curious up here that all these had like similar size ratios, but some were negative, some were positive. Not sure why that happened. So we're trying to figure that out. So we know we can talk about standard position angles, and that goes clock or counterclockwise is positive, we said. And then if we wanted a negative angle, we would go that way. We can go more than 360, and we did all those things. So then today we're going to add the idea of this thing called a reference angle. So for any angle on our coordinate system, so here would be my initial side, here's my terminal side, this is my angle theta, there's this thing called the reference angle. It's a positive acute, hopefully you remember acute, that means less than 90 degrees, so it has to be less than 90. It's formed by the terminal side, so in this case, this is the terminal side, this is the terminal side, this is the terminal side, it's where my angle ends. So I go from the terminal side, it's the angle between that and the x-axis. So when we think about it, from here, we're always going to go to the x-axis. So I came around to here, and then I'm going right there. Boom, that angle right there. Keep going, that's the angle, that's my reference angle. Or to do my angle itself, theta came to here. All right, now when I want to go to the x-axis, I'm actually going to go back that way. That's my, what we're going to call theta prime, or my reference angle, right? If this is my angle and I come all the way around here, that's my theta. The reference angle from this terminal side, that's the theta prime. So we have that idea. And we're going to try and figure out what those numbers are. So if we think about it, right, how can I get it? Well, if I think about this angle right here, all the way to here, that would be 180, and I only want to go to here. So we're going to do 180 minus theta. Right here, if theta is all the way to here and I want to know how big this is, well, I could take theta and subtract 180 degrees. And if I want to know this angle right here, I could think about, well, it's 360 all the way to there. And if I subtract theta, if I subtract this angle, it should give me my reference angle. Okay, so those are sort of how we calculate it. I think it'll be easier to see with real numbers. So let's try a couple. So these are some of the same questions we did in the previous video. where we had our angle in standard position. So let's start with this one of 345, okay? So if my angle is 345, again, I start here, and I'm gonna go around, I pass 90, I pass 180, I pass 270, I come here. So this is my 345 degrees. Oops, that'll be a 5, okay? But my question is, the reference angle is that angle right here. Sort of, it's like, what's left to do? And to find how big this is, see if you can do it on your own. Well, I'm gonna say, if this much is 345, and this much is 360, to get the reference angle, I could take 360 and subtract 345, and I get, I think that's 15 degrees. Boom. That would be how big my angle is. Clearly, I didn't draw my picture very well, but you get the idea. All right, let's try the next one. So my reference angle for an angle of 250. Again, I started here for 250. This would be 90. This would be 180. This would be 270. So I'm going to stop before I get to 270, right? So this far would be 250. And again, the part that I want is this angle right here. So I have passed 180, and I want to know how much. So that angle right there, how big is it? Well, if I take 250 and I subtract the 180, right? So I want to subtract all of this part, and that'll give me what's left, which is going to be, I must have gone 70 degrees past 180, and that's how big theta prime, or the reference angle, is. Okay, let's try a couple more. Here we go. Negative angles. Do you remember how we do negative angles? So with a negative angle, I still start here. I always start at the positive x-axis. But now, instead of going counterclockwise, nope, we're not going to do that. We are going to go clockwise for a negative angle. We're going to go 150 degrees. So I'm going to come around, come around, come around, whoop, right about here, somewhere, maybe a little farther. Okay. And then I want to know how big that angle is, because from here to here. Well, if this was going 150 and this would be going 180, what's left? Well, this must be that difference. So it's going to be 30 degrees is my reference angle. We could do this last one, 390. 390, holy moly. Okay, bigger than 360. So I'm going to go all the way around to here, and then I'm going to keep going a little bit until I hit 390. So this is 390 degrees. This was 360 right here. My reference angle is this right here. How much beyond? Because it's to the x-axis. And so how much farther beyond 360 did I go? I could do that by saying 390 minus 360. And I get 30 degrees. So one thing we want to think about when we're finding reference angles is we'll also make triangles. Like you could make triangles from those reference angles. But I think we'll do that in the next video. So hopefully you are now able to draw an angle in standard position on our coordinate plane and then find the reference angle for any angle in standard position.